Hi everyone. Today we're going to talk about a couple of different kinds of equations. And the first of those is are going to be the rational equations. Okay, so what it means to be a rational equation, that means you have an equation, remember all these have to be equations, we have to have that equal sign, that has a rational expression. So rational, that's just the mathematical way basically to say fraction, right? So these are rational equations, not just because they have a fraction in them. For example, let's look at this equation. That's not a rational equation, okay? This is a linear equation because to determine what kinds of equations we have, we look at what's being done to the x. With a linear equation, our exponent is a 1 and only a 1. Remember, with a quadratic equation, the biggest exponent on the variable was a 2, right? Well, now, so what we're going to have equations like this, perhaps. This is what makes them linear equations, that variable in the denominator. This is what makes them rational equations. We've got a variable in the denominator. But what I want to remember is it still works just as if it was a regular fraction with just one small exception. Okay, so if we had this equation with a fraction in it, I hope we all know our first step on any equation, if it has a fraction, is to get rid of that fraction. And the way you get rid of the fraction is just simply multiply by whatever your least common denominator is. In this case, I only have one denominator, so I'm going to multiply everything in the equation all the way across by 2. Okay, that allows me to eliminate that denominator, and then I would just have x plus 6 equals 2, and I've got an equivalent equation that doesn't have any fractions, so I can easily solve that. It's exactly the same up here. I'm just going to find my common denominator. Now, that might be a little bit tricky because our denominators are going to have variables, so we'll have to mention how we're going to do that. But in this case, since I just have one denominator, I'm going to multiply everything by that denominator, which is x. Okay, that allows me to eliminate the denominator, so that all I have left there is 1 plus 3x equals 1x, and I have another simple linear equation I can solve. Okay, so if we have a rational equation, which means it's going to have fractions where there are variables in the denominator, all I'm going to do is get rid of that denominator. Okay, so to get rid of the denominator, we need to find the least common denominator of all terms. We need to talk about that. We're going to multiply each term by that least common denominator, which we just showed up there. Except remember this, not inside parentheses. Not inside parentheses. When you multiply a term, it automatically goes inside the parentheses when you distribute to get rid of the parentheses. So multiply each term, but not inside parentheses. And then you just solve whatever remaining equation you have. Okay, now here's the little difference I was talking about. Because a rational expression is not defined when its denominator is 0. In other words, the easy way to say that is denominators can't be 0. We all know you can't divide by 0. You can't divide by 0. You can't divide by 0. So we've got to make sure and check our answers to make sure that, for example, if I solved this equation and I happen to wind up with x equals 0, then when I look back at that denominator, oh no, x cannot be 0. So that would be an equation that I would not have an answer for. So that's the only difference in just a regular equation with fractions, right, is at the end I have to check my answer if those fractions have variables in the denominator. Okay, so you might want to have your steps written somewhere. Let's practice this. Okay. Okay. So first of all, let's talk about finding a common denominator. As a matter of fact, this one over here already has a common denominator, right? But right here, to find a common denominator, and so you may want to write this down also. To find a common denominator, factor all your denominators, and then you take any factors they have in common plus any additional factors, and that's your common denominator. So I don't see one on this, but we'll do some examples later where we actually have to find a common denominator that's not quite as simple as these. Okay, so first step, I notice that it is a rational equation. So, if it's a rational equation, I need a common denominator. To find a common denominator, factor all your denominators. That doesn't factor any further. That doesn't factor any further. So then I'm going to take anything they have in common. Well, a factor of 3 and a factor of x minus 1 is nothing in common. So then I take everything. So 3 times x minus 1. That's my common denominator. Now, I'm going to multiply everything in the problem, every term, and this is a term, right? Terms are separated completely by plus and minus signs. This is a term, and this is a term. By 3 times x minus 1. All right, so I'm going to multiply this whole thing times 3 times x minus 1. I'm going to multiply this whole thing times 3 times x minus 1. And I'm going to multiply this times 3 times x minus 1. Every term, not inside parentheses. Okay, so now that means in this term right here, only in this term, everything's multiplied together up here, that I can get rid of these 3's. So what's left right here is just 3x minus 1 times x minus 1. Okay, then I got a minus sign, so be careful of that. Over here, this x minus 1 can cancel with this x minus 1. So all that's left right here is 3 times 2x. Now this doesn't have a denominator, so this whole thing gets multiplied together. 3x times x minus 1. And look, there's my equation, and it doesn't have any fractions in it. Okay, so first step is always, let's get rid of these parentheses. Let's distribute here. So we wind up with 3x squared minus 3x minus x plus 1. Okay, minus 3 times 2x is minus 6x equals 3x squared, distributing again, minus 3x. Okay, now notice if we subtract 3x squared from both sides, those second degree terms are eliminated, and hey, we just have a linear equation here. So let's combine our like terms. Here's all my x's on this side. So negative 4x minus 6x, negative 10x. Don't forget there's a plus 1. Equals negative 3x. To solve a linear equation, we just put all our variables on one side, numbers on the other, right? Let's add 3x. So, negative 7x plus 1 equals 0. Subtract 1, negative 7x equals negative 1. And divide by negative 7, so x is 1/7. Now, the only difference in this and a regular problem with fractions in it is I now have to check and make sure it doesn't make a denominator 0 before I box my answer. So that's a number, so it can't be 0. 1/7 minus 1, I don't really care what it is as long as it's not 0. And 1/7 minus 1 is not 0. So I have a valid answer. Okay, over here, since they both have the same denominator, excuse me, that is my common denominator. So I know my common denominator is x minus 2, so I'm going to multiply every term by that denominator, x minus 2. Okay, so right here, the x minus 2's can cancel, and all that's going to be left is just that x. Here also the x minus 2's can cancel, and all that's left is the 2. But then here I have 2 times x minus 2 because that cannot cancel. Okay, get rid of those parentheses. 2 plus 2x minus 4. Linear equation. So I want my x's on one side. So I have negative x equals 2 minus 4, negative 2. Divide by negative 1. X equals 2. And don't forget, before you box your answer, I've got to see and make sure if it makes the denominator 0. Or, uh-oh, if I put a 2 right there, 2 minus 2 is 0. So that means never leave that. You mark it out and say, no, x does not equal 2. And here's what your answer looks like. This is the symbol for the empty set. It means no solution. The set of answers is empty. So if you're writing your answers, this is what it looks like. On your MyLabs Plus, you're going to have an option where it says the answer is x equals, and you put in a 2. Or it's going to say there is no solution, or there are infinite solutions, something like that. And you'll just choose the, there is no solutions box. But when you're writing it out, you're not doing it on a computer, this is what your solution looks like, right? This is this empty set symbol. All right, let's try some more of those where we need some practice on finding those denominators maybe. Okay, it's a good one, I hope. Okay, so first thing I notice is it is an equation, so I am trying to solve it. It's got variables and denominators. It's a rational equation. That means I need to get rid of the fractions. Okay, really, it doesn't matter if it's a rational equation at this point. Once I see fractions, that's my first thought. Oh, an equation? Got to be an equation. Cannot get rid of fractions on an expression. But okay, getting rid of those fractions. So to do that, I need every denominator to be factored. That's factored. That's oh, this one I can factor out an x, and it leaves x minus 2. Okay, once everything is factored, I take any factors that they have in common. Hey, these two denominators both have an x, and these two both have an x minus 2. So anything they have in common, I take them. And then I take any extras. Well, there's nothing extra there besides what I already have written. Nothing extra here, nothing extra here. That's my denominator. I'm going to multiply this denominator by every one of these terms. Okay, so I'm going to multiply this by x times x minus 2. I'm going to multiply this by x times x minus 2. I'm going to multiply this by x times x minus 2. Okay. So now in this term only, I see, oh, there's an x minus 2 and an x minus 2. Right? So I can get rid of that, and that just leaves now an x times 3x plus 2. Okay, you got a plus sign. Okay, now here, there's an x and there's an x. Anything that's the same on the top and the bottom can cancel out, so that just leaves 1 times x minus 2, or just x minus 2, right? Now notice over here, the x can cancel and the x minus 2. So all that's left is the negative 2. Okay, so there's our equation that doesn't have a fraction. Let's get rid of parentheses, so let's distribute that x. 3x squared plus 2x plus distribute that 1, x minus 2 equals negative 2. This time I've got a quadratic equation. So instead of putting variables on one side and numerals on the other like we do in a linear one, I'm going to set it equal to 0 and see if I can factor it. So as I'm rewriting it, to set it equal to 0, I'm going to go ahead and combine these terms. So plus 3x. Oh, and then look, plus 2, plus 2. So both of those goes away. So that makes it easy to factor. I can just factor out that common factor of 3x, and that leaves x plus 1 equals 0. So that means we got a bunch of stuff multiplied together, right? So either 3 is 0, x is 0, or x plus 1 is 0. Now 3 is not 0, right? That's not the one that's 0. At least one of these is. 3 does not equal 0. I cannot make it equal 0. This is already solved for x. If I subtract 1 here, I got negative 1. Now don't forget, we got to check these answers. So 0. If I put 0 minus 2 is not 0. I don't care. If I put 0 right there. So this also is not a valid answer. Let's try negative 1. Negative 1 minus 2, that's not 0. That's not 0. And neither of those are 0. So there's my answer. Only x equals negative 1 in this case. Okay, let's try it again. Okay, it's a rational expression, so I need a least common denominator to get rid of those fractions. That means I need every denominator to be factored. Already factored, or won't factor any further, won't factor. Oh, it's the difference of squares. It factors as x plus 1 times x minus 1. So I'm just changing that to its factored form. Now I'm going to take whatever they have in common. Hey, these have an x plus 1 in common. And these have an x minus 1 in common. And any extras. If I go back and check and there's any extras that's not already accounted for right here, I'm also going to add that to my list. But I've already got that one, I've got that one, I've got both of those. That's my least common denominator. So once I figure out my least common denominator, I'm going to multiply every term by this denominator. So up here, everything gets multiplied by x plus 1 times x minus 1. X plus 1 times x minus 1. X plus 1, x plus 1 times x minus 1. Right here, I can cancel out that x minus 1. And all that's going to be left then is negative 4x times x plus 1. Okay, got a plus sign. Here I can cancel out that x plus 1. And all that's going to be left is the 4 times x minus 1. And here I can divide out the x plus 1 and the x minus 1. Right? So equals negative 8. Okay, get rid of parentheses. Distribute negative 4x squared minus 4x plus 4x minus 4 equals negative 8. It's quadratic again, so I'm going to set it to 0 and try to factor it. Oh, look right here. Negative 4x plus 4x Okay, so if I add 8 to both sides, let's add 8 to both sides, I get negative 4x squared plus 4 equals 0. I don't want this leading coefficient to be negative. Plus, look, I can make my number smaller. So let's divide everything by negative 4. Let's divide everything by negative 4. So if I divide this by negative 4, I get positive x squared. If I divide this by negative 4, I get minus 1 equals 0. This is the difference of squares, so it factors as x plus 1 times x minus 1 equals 0. That means either x is negative 1 or x is positive 1. Don't forget to check your answers. So negative 1, let's see if we can see our denominators a little more clearly. Negative 1 minus 1, that's okay. Uh-oh, negative 1 plus 1, this isn't an answer. Okay, oh, 1 minus 1. I didn't get any valid answer. This is another no solution one. Okay, let me know if you have any questions on those. Okay, the other kind of problems we're going to talk about today are another kind of application problem, but they're a specific kind of application problem. And once you're told the method for solving them, you know, it may not be something you could come up with easily on your own, but once you're told, they all work the same and they're really very easy ones. So a work rate problem, and that's what they're called, is when you have more than one thing working on the same activity, right? You can have 2 or 3 people painting a house, or in this example, mowing a lawn. You could have 2 people grading papers, 2 copy machines. A lot of it is pipes running in to fill up, or 2 faucets are open in your sink, things like that. So the key to solving a work rate problem is to figure out the rate at which each is working, the per hour, per minute, per second. So for example, if it takes me 2 hours to paint a wall, then how much wall do I paint in 1 hour? Half of the wall, right? So here the 2 in the denominator comes from how long it takes me to paint the wall. Okay? If it takes me 5 hours to mow my lawn, then I can mow 1/5 of my lawn every hour, right? And we just multiply it by x, where that's the number of hours. So in 1 hour, I've mowed 1/5 of the lawn. In 2 hours, I've mowed 1/5 times 2, or 2/5. In 5 hours, I've mowed 1/5 times 5, or 1 whole lawn. So all of these problems are based on this idea. Put it down to the hourly rate, the minute rate. Okay, so let's look at a couple of those. If Joe can paint a house in 6 hours and Sam can paint the same house in 8 hours, how long does it take them to do it together? Well, let's figure out what each one's hourly rate is. Sorry, had to get a drink. So if Joe can paint the house in 6 hours, he can do 1/6 of the house every hour. And if Sam can paint the same house in 8 hours, he can do 1/8 of the house every hour. If they're going to work on it together, we're going to add those. Now, here's something that you might not think of, but what I want this to equal is 1. It's always going to equal 1. When do we have 1 whole house painted? 1 whole pool field, right? 1 job completed. Now, once we have this, notice it's got fractions in it. So I need my least common denominator. The least common denominator between 8 and 6 is 24. Yes, you could have used 48. It'll just make your numbers bigger and you got to simplify more. The least common denominator is nicest, but any common denominator will work. Okay, so now 24 divided by 6 leaves 4. So this becomes 4 times x. 24 divided by 8 leaves 3. So that's 3 times x. And 1 times 24 is 24. It's now a simple linear equation. 7x equals 24. So x equals 24/7. Now again, if we were just solving this problem and it didn't have an application question to go with it, we could leave 24/7. But since this says how long does it take them to paint the house, you know, if a painter comes up and they say, well, it'll take me 24/7 hours, you're going to think they're nuts. So we need to change this to 3 3/7 hours. All right, just under 3.5 hours working together, which should make sense also. If Joe can paint the house by himself in 6 hours, you better have a number less than 6, right? If someone's helping him. Okay, an inlet pipe can fill Blake's pool in 5 hours, and an outlet pipe can empty it in 8 hours. If Blake accidentally left both pipes open, how long would it take to fill his pool? Okay, so if the inlet pipe fills it in 5 hours, how long does it fill it every hour? That's right, 1/5 of the pool is filled every hour. An outlet pipe empties it in 8 hours, so 1/8 of the pool is emptied every hour. But this time, now if it said there were 2 pipes running in, I'd put a plus. But this time, this one's emptying it. This is running in, this one's emptying it. And it always equals 1. 1 full pool. Okay, common denominator is 40. So let's multiply everything by 40. 40 divided by 5 is 8. So this is 8x. 40 divided by 8 is 5. So this is 5x. And 1 times 40 is 40. So simple linear equation again. 3x equals 40. So dividing by 3, x equals 40/3. So what's that? 13 1/3 hours. Which again, if the pool can fill in 5 hours, it should be longer if you're at the same time running water out. So 13 1/3 hours to fill it now if you leave the drain pipe open. Okay, guys, I think that's it for this section. So let me know if you have any questions, need anything at all, and I'll see you next time.